Upregulating the regulatory capacity of complex systems. Complex systems have a bunch of different regulatory dynamics that interact with each other in ways that we only understand a little bit. And so, and different kinds of complex systems have different kinds of regulatory dynamics, and we have to get clear which ones are going to be the right models for economics, for civilization as a whole, for governance, for infrastructure. So specifically, we have complex adaptive systems that don't have clear boundaries and don't have any centralizability of information. So a forest is an example, right? Or any kind of ecosystem is an example where that whole thing can't behave as one autonomous unit in any kind of real-time capacity. There might be coordination of things like mycelial networks that will share resources, but this is a very slow kind of response curve. And so there are dynamics of how that is a complex adaptive system, but that doesn't actually have singular agency, right? And that's defined by a lack of membrane, lack of self-organizing membrane that separates the complex system from everything else that allows agency of what's on the inside of the membrane in relationship to the environment outside. We see then, the earliest membranes are prokaryotes, and they have the capacity to navigate with agency in relationship to the environment. Then as we start to get into eukaryotes and slime molds, we get into something where you have multiple steps of boundary. These are, you can think of these as superorganisms comprised of simple organisms. And so here you have to get the agency of different things to participate with a high coherence, which is already happening in the forest, but participate with a different kind of high coherence where they don't have competitive dynamics with each other. They have coherent dynamics with each other and maybe competitive dynamics outside of that boundary. And then you get a new boundary outside of it, right, which is the biofilm around the slime mold. And then that whole thing starts to operate as a unified organism, even though it's a superorganism of smaller organisms. That's a totally different kind of behavior than just the individual organism, because the individual organism doesn't have to take agents and create coherence between them, right? Whereas the superorganism that, like a forest, that is not yet a secondary organism, doesn't also have to create certain kinds of coherence. It just has to create homeostasis, predation cycles of balance. But then the next one, where you get, a slime mold boundary, or a eukaryote that is made of kind of prokaryotic-like dynamics, now you have to get separate agents to cohere and then become a new meta agent, right? Then that starts to evolve in eukaryotic systems to greater complexity, and as soon as we add a neural net, we start to get a different kind of way of centralizing information across this kind of complex that allows a lot more adaptive capacity than the slime mold has. The slime mold is only going to do chemical signaling, which is going to go very slowly. And the something that has a neural net is going to be able to actually coordinate behavior of lots of organisms from a top-down fashion. So you can actually start to have a boundary. Anytime you have a boundary, you start to get some top-down coordination, but then you have phases of what kinds of top-down. So then you go from distributed neural net to central nervous system, and then higher kinds of central nervous system. And so top-down organization is actually an emergent property of certain kinds of bottom-up organization, right? You get bottom-up organization of separate cells coming together to make up a human, right? 100 trillion autonomous agents that function more coherently together, and it's adapted for them to be together than separately. And each cell is regulating its own function genetically, internally, in a bottom-up fashion. But then the top-down neuroendocrine control of massive groups of cells, where the top-down system is sensing the entire system and then can do coordination of the whole system, but sitting on top of bottom-up dynamics, which is, if the cells weren't still doing their own thing genetically, the top-down system wouldn't work at all. But if the top-down system is not working well, like a person's in a coma and the highest functions are turned off and only autonomic is on, the bottom-up is working just as well, but it doesn't have the same capacities at all, right? You have emergent capacities that relate to boundary and top-down capability. Which of these are models for what civilization will be, right? Is it going to be individual humans that are just like a forest, that don't have any kind of boundary around it, and we just get balanced through getting the right kind of predation cycles and equilibriums? Is it humans as a slime mold that are working together but without central top-down control that a nervous system would give? Or is it what kind of level of nervous system that has centralizable capacity, and then at the level of human nervous system forecasting ability, right? Rather, and abstraction from giving forecasting ability. It's a super deep question, because also our human consciousness and human sense of self is the emergent property of the coordination of all of these things working together. But if all those things are working together, but without certain kinds of synergistic dynamics, you don't get human consciousness, i.e. a person in a coma. You don't have the same thing. So is humanity going to become a superorganism that actually has its own agency, right? And we're building that kind of nervous system of humanity. Or is humanity a boundaryless non-agent, but we're at least getting the kind of coherence between agents that keeps it from self-destructing? Those are fundamentally different kinds of complex adaptive systems. They're different relationships of, they're different mereology, right? You have a different relationship between the parts and the other parts and the parts and the whole. And then totally different forecast of what kind of capacities are going to come about. So if we simply do the libertarian model is totally bottom up, right? How do we get people to be individually good choice makers and good at making deals with each other that are effective, and no top-down structure? All of the anarchy models basically are those kinds of models. But as soon as we have complex decisions to make, complex choices to make that involve lots of us and data capacities that individual humans can't do, which we have lots of that if we don't address we go extinct, and the question is, that has to sit on top of the good libertarian-like framework of individual people making good choices. So that's necessary, but it's not sufficient, right? There are things that will have to be decided on by large groups of people and participated in faster than would happen through bottom-up only dynamics. So now this is the next topic, which is our ability to affect things and our ability to make good decisions regarding how we affect things have to be paired. Otherwise, if we can affect things but we're not making good choices regarding how we affect things, then the externalities that start compiling become problematic. As our ability to affect things is on an exponential curve right now, if our choice-making capacity is not similarly on an exponential curve, that is a fundamentally self-terminating scenario. So exponential tech, this was the third scenario you brought up, exponential tech gives individual agents and small groups of agents capacities that never happened before. So when you think about Nash equilibriums and wanting to get us out of fucked up Nash equilibriums, you don't need everybody to do the right thing, because individual agents all have quasi-equal power, and the worst thing, and to get it to be really fucked up, everybody has, or a certain critical mass of people have to do the wrong thing. In a dynamic where you have exponential tech that is powerful enough to be catastrophic, that can be decentralized, everybody's choice-making matters. So how do we deal with that is a totally different thing, right? And so for humanity to make it through, us individually and in small groups scaling our actuator capacity up exponentially, our choice-making capacity regarding what we do with that actuator capacity and our feedback loops on it also have to scale up. Now, whenever we developed new technology in the past, we did heaps of destructive applications, but the technology wasn't so bad that it destroyed everything. We burned a lot of shit down with fire before we kind of learned how to manage fire to be more positive than negative, but you can't do that with nukes, right? And you can't do it with CRISPR because it's not, the impact potential is radically more than it was with fire. And so how do we take our new emerging technologies and do something with them that is radically different than we've ever done with any technologies in the past, which is adequate anticipatory process so that we don't learn from trial and error on things that are too powerful to learn from trial and error. That's a totally different set of scenarios that we have to address. So then we get into the issue of incentive. One of the things is that we have to, you can't avoid a problem while you incentivize it. You also can't solve a problem while you're continuing to incentivize it at scale. One of the problems with exponential tech and why we are not doing a good enough job of thinking through the problems of exponential tech slowly is because there's a lot of fiscal incentive to get there first. And there's not that much fiscal incentive to really think through the issues, in a long, slow, deliberate, thoughtful way. And so
it's funny, we're externalizing extinction.
We are.
It's a good way of thinking about it.
We are increasing the probability of extinction for the probability of winning in the in the near-term profit game that will be obsoleted in the process, but each of those increasing the probability of extinction compound on all the other ones till the probability reaches 1, right? And it at the current trajectory, it is inexorably reaching 1, 100% probability of extinction. And so you have to change that whole fucking thing. So you can't have an economic system that incentivizes speed on things that have to go slowly, right? I can't underscore that one enough. But then that also brings up the issue of incentive in general with complex systems is how do you get a bunch of individual cells or algae or whatever to work together into a superorganism rather than compete with each other? Well, you have to change the behavioral dynamics from competitive to cooperative. You have to change all the things that affect behavioral dynamics. So incentive is one of the major categories of behavioral dynamic. As long as we have any systems of incentive, and then we'll go larger past incentive. So kind of diving into systems of incentive more, if as there are more humans than there have ever been, right, exponentially more, and the impact per capita capacity of the humans is also been on an exponential curve, and it's at an exponential curve point that is reaching escape velocity. We can kind of metaphorically say we are achieving the power of gods over the next little while. Without the wisdom, discernment, care of gods, that is a inexorably self-extincting scenario. So how do we deal with that? You kind of can't put the technological curve cats back in the bag. That's an impossible thing to do outside of just fail scenarios on what we call civilization right now. So you have to come up with adaptive capacities in factoring for that level of technology. And so if you think about, as we have that much capacity to affect stuff, and there's that many of us affecting stuff, that means the ability for humans to affect other humans, and the ability for humans to affect the ecosystem, and all of the cascade effects of both of those are radically increased. Now the total, humans affecting the ecosystem is right near breaking points of the biosphere losing key life support capacity. And even before it loses life support capacity overarchingly, i.e. there's no viable places to live, you start losing certain viable places to live. As soon as you start losing certain viable places, so climate change causing severe droughts where farmers have to move out of those areas into cities, which is what happened in Syria, lowland areas, flooding, etc., then you start to deal with massive migrations, refugee issues, and then resource wars, and then fragile grids collapsing. And so we're not just looking at ecosystem scenarios just in terms of the ecosystem by itself, but ecosystem scenarios and culture issues, war issues, resource issues, fragile grid issues. Any of those, they're all interconnected enough, and there's enough fragility across those systems that failure in any of those systems can lead to catastrophic cascades currently. So as we have that level of capacity to affect things, the coherence of everyone affecting things in neutral to positive ways is critical, right? It is existentially necessary. So how do we get that much coherence? Well, we have to get coherence amongst the behavioral dynamics, right? So that people are behaving in ways that net benefit the balance sheet of the commons and each other. So let's just talk about incentive for a moment. Like we said, you cannot incentivize a problem and prevent that problem from happening simultaneously. And just, it's really important to get, you cannot legislate against incentives successfully long-term ever. If you make a piece of law that says it's illegal to do this, but it's still profitable to do this, the companies can always move headquarters to another country and then pay taxes there, which actually makes a market for countries to make law that's more favorable to shitty things, right? Whatever that incentive is. And yet, so the companies really are not under the full jurisdiction of countries, and yet countries, the people who need election budgets and the people who need campaign budgets are under the jurisdiction of whoever can fund those things. And so economics as an incentive system, you ultimately can't confer resource and advantage to certain kinds of behavior and prevent those behavior through agreement fields that are still subject to the resources, the pools of accrued resources. And so it's important to get that, because any strategy that says we're going to solve climate change through primarily regulation. We're going to solve war, whatever, through regulation, while the incentives are misaligned, has never and will never lastingly work. You can get temporary blips. That's about it. And so, what that looks like is, if we want a world without war, we can't have any incentive for war. And we have to have incentive for collaboration, cooperation, etc. So where is their incentive for war? Well, let's start with the obvious. You can't have the largest block of global economy be a military-industrial complex that stops existing without war, and have war stop existing and have it continue, right? So its own continuance requires a reason for its existence. So any model of lasting peace and reconciliation that obsoletes militarized conflict has to obsolete a for-profit military-industrial complex, or it has no chance of succeeding. So any strategies that aren't trying to do that have no chance of succeeding. That's a big deal, because so far everything that has tried to do peace and reconciliation hasn't been focused on that at all, which means that none of those things ever had any chance of succeeding. Now then, we can also look at, as long as you have separate balance sheets that have interest on ownership that encourages hoarding and competition in a zero-sum finite game dynamic, then just resource ownership encourages war, right? Because it ends up being, we're fighting over things, and fighting always ends in a force dynamic at the end of the day. And so can you have freedom from war as long as we have zero-sum game dynamics? No. So this is, not only do you have to get rid of a for-profit military-industrial complex, you have to get rid of zero-sum games, period. Because as long as you have zero-sum games where losing at the game ends up meaning can't support the people of your country adequately, means losing adaptive and competitive power, means all that, then it is a survival to not lose at those games, and which means military is going to come in. And that means that you're going to keep doing the zero-sum fucked up thing of arms races, right, to continue to maintain adaptive power, which means you put all the resources into the exact wrong things that not only don't support life support of anything, and that don't make the scarce resources better utilized, but make the scarce resources poorly utilized and increase our risk of extinction every bit of the way, because if anyone does it, everybody has to do it. So to go deep with that, any system of differential advantage, right, finite games that are zero-sum, which means any private balance sheets that will always end up generating those, meaning there's scarce resources and we're competing for the scarce resources, and you possess them rather than have access to them, and you possessing them means I don't have access, and the more that I possess, the more I do better at every level of Maslow's hierarchy. That inexorably leads to dynamics that will continue to cascade into progressively worse clusterfuck. So we've basically, since private balance sheets, we've had wars over resources. It's just as we keep getting more and more people, and as the legislative ability, the judicial ability to try and stop bad acting from happening is less and less capable, as economics has learned better and better strategies to deal with that, and our technological capacities are increasing and our population is increasing, those strategies that always resulted in unrenewable destruction of resources and war just lead to unrenewable destruction of resources that end the biosphere's capacity to support life, and more that ends the biosphere's capacity to support life, and technology that's powerful enough that even accidentally ends the capacity to support life. So we've actually been on a trajectory towards this inexorably, as long as we've been on private balance sheets, and then all of the additional dynamics that have kicked in, limited liability, etc., have been kind of inexorable evolutionary byproducts of differential advantage to begin with, which means we've been individual agents that had not yet cohered into a superorganism. And basically we're at the point now where those organisms are fighting each other with a strong enough capacity to destroy the whole ecosystem in which they live, so it doesn't work for any of them. So they either have to unify into superorganism or die. That's kind of where we're at. And so then it's, how do we unify into superorganism? Well, how do you get all of the agents to align their agency? So how do you make sure that the incentive of every agent is as close to perfectly aligned with the well-being of every other agent and of the commons as possible, so that all the internalities are externalized, so that we are conferring advantage and resource to that which is omnipositive. we're not conferring advantage and resource to that which is externalizing harm. Economics sits right at the intersection of worldview and infrastructure, because worldview is, what do we value? We value our people, our religion, our nation, our skin color, whatever, more. So, worldview is, what do we value that is the basis of what we're working towards? Infrastructure is, how do we meet our physical needs in relationship with the physical planet and build tools of advantage, right? Because we increase our adaptive capacity. Unlike other animals where they're just corporeal tools, give them adaptive capacity, we extend ourselves through our extracorporeal tools, and so infrastructure is the extensions of ourself that lead to the adaptive capacity of the group that is developing those. And so economics sits right at the intersection between value systems and our increased physical adaptive capacity, because it's how we codify value systems in a value equation. What are we actually going to ascribe value and confer power to, right? If we're looking for differential advantage, then there's no real way to get differential advantage from air. There's enough of it, everybody can have access to it, so it's worth nothing. Because it's worth nothing, we have no economic incentive to not burn it up and pollute it, right? If there's a resource that there's not that much of, then I want to own it because I get differential advantage, even if that provides only symbolic advantage. So all the gold sits in safes. We don't actually do anything with the gold, but because there's a scarce amount of it, or at least a believed scarce amount of it, we will ruin ecosystems and fight wars to get the gold to put it in safes that provide no utility value to anybody. So that, or the whale being worth real tangible money dead on a whaling boat, but nothing alive. What does it mean that the commons has no balance sheet, that is respected? That's a set of value systems, right? Differential advantage value systems that are then codified in a value equation that then determine what technology and infrastructure is built and how it's applied. And so we have all of those, our value systems, our infrastructure and tools, and our social systems, economics, governance, law, language, they're all inter-affecting each other. But we can simply say, to move up, and they're all inter-self-stabilizing. So you actually can't have an omni-considerate worldview as long as you have infrastructure where meeting your needs requires hurting the rest of the world, because in order to meet your needs through that system, you have to justify doing it, which means you have to downregulate empathy. So do tools affect our worldview? Absolutely. Inexorably, right? They're all inter-affecting. So we have to move our worldview, our social systems, and our infrastructure holistically the next self-stabilizing complex up. So what we're interested in is, what are the necessary and sufficient activities, transforms that have to happen in each of those areas to lead to a new self-stabilizing dynamic that is anti-fragile in the presence of all the dynamics we're actually facing over the next period of time. So anti-fragile to exponential technology. So in order to move up to the next self-stabilizing complex, we can actually define the high-level criteria of what has to transform in each of those categories and how they interaffect each other. And we can define all of them in terms of closing causal feedback loops that have been open. So in the area of infrastructure, part of why infrastructure has been, why it is fundamentally not only unsustainable, but that means self-terminating, is because we have primarily a linear materials economy where we're taking stuff out of the earth faster than it can renew, and then turning it into trash and putting trash back in the earth faster than it can be naturally biodegraded. So that means we are converting a living ecosystem into dead zones and trash at a rate that requires exponential year-over-year growth of the total linear materials economy, right? Because the capital has to expand year over year, and that sits on top of the materials economy. To not debase the currency, you have to increase goods and services, etc. So we have to close that loop where the stuff that was trash becomes the basis to make new stuff, and we have continuous closed loop cycling that is post-growth, meaning it doesn't require growth. It doesn't mean it can't ever grow, but we have a system that is actually stable without more net atoms coming into the materials economy. Now we're going to be getting more photons all the time, right? We're going to be getting input of energy, so it's not a closed system, but it's, let's say it's closed to atoms, or it's at least doesn't require input of new atoms. Well, then you can continue to upcycle the atoms, right? You can take the trash and turn it back into new stuff, where the new stuff keeps upcycling into higher and higher forms because you keep having new energy and new pattern, right? New information and design. We have to have a system that is closed loop, post-growth, and upcycling as far as the materials economy goes. If it's not those things, it is mathematically self-terminating.
And by the way, we can connect that set of ideas back to just the basic framework of how complex adaptive systems self-regulate in general.
Yes.
The idea is that this is a generalized problem. Daniel's now talking about how this generalized problem applies in the zone of anthropomorphicity in
Correct.
particular.
So when we study complex adaptive systems, one of the things that we see in all of the complex adaptive systems is that they are defined by closed causal feedback loops and then massive parallel processing. And so closed causal feedback loops means every organism is defined by its capacity to sense the environment, right? Sense the environment and itself, so it's external and internal sensing. Sense making, information processing capacity of all that to then be able to actually have a sense of what's really going on from all those sensory channels and all the past information, etc., to then inform action, and then actuator capacity to act on the world. And then the ability, why it's closed loop, is that it can sense the way that it acted on the world. And then that worked well or it didn't work well, now we're gonna go left, now we're gonna go right, and so it can continue to upregulate its capacity with closed loops. And you think about, so that's sensory systems, motor systems, and cortex or information kind of processing systems, right, in animals, the way we think about it. Those necessarily co-evolve because there would be no evolutionary advantage and a lot of evolutionary disadvantage to sense stuff that we couldn't act on, right? We'd just be freaked out about stuff. Or if we acted and couldn't in turn sense the effect that had happened, then we would have no way of knowing if that action was adaptive, right? So it would mean we do a lot of non-adaptive action. So those three co-evolve and they define the organism, right? Well, what happened with humans, our capacity for abstraction allowed us to see what we were doing in all those areas and build tools that extended those capacities independent of each other. So we started to, as our tools grew, break open that feedback loop. So we started with mostly actuator tools, right? Hammer would extend our fist, and plow would extend our digging ability, and extend that now to our fist is extended through the entire military-industrial complex, right? And intercontinental ballistic missiles are extension of that capacity. And the entire industrial supply chain is the extension of our capacity to go pick something or cut something down. Well, if I'm affecting things every time I purchase across all the continents through massive globalized supply chains, I can't sense what's happening at all to inform my decisions, right? That's a completely broken open causal feedback loop. In turn, I can sense stuff through the internet and billions of pages of everything from from Hubble telescope to electron tunneling microscopes to everything in between. But there's more information than we can actually vet if it's true or not, parse and synthesize together to actually know what's really going on anywhere. So our sensory input we can't actually make sense of. And then to the degree that we can make sense of things, so we've also extended our capacity technologically with computation to make sense of stuff. But then if we really get climate change is real, we don't know how to fucking act on it, right? So basically we have broken open our information processing systems, and that is core to why we're non-adaptive, right? It's core to why we are doing quarterly actions that are increasing our risk of extinction, is because we don't factor what's happening well enough, put all the pieces together to inform decision making, and continue to cycle that. So we have to close the incentive loop, so that the incentive of some agents and the well-being of other agents in the commons, since they inexorably interaffect each other on a little biosphere where we all have increased capacity to affect each other. That's actually another key part to say is, when our capacity to affect each other was not existential, the idea of winning a win-lose game made sense, right? Let's make sure our military is better than theirs and we can actually win this thing. When we both have nukes, nobody can win, right? And the idea of being able to just beat them economically by we can cut down trees faster than they can and actually just build up more economic surplus, when we weren't at risk of cutting down all trees, right, or overfishing the entire ocean, that made sense. Win-lose games at our level of power are all lose-lose games. So basically win-lose has become an obsolete game theoretic model. Now we either have win-win or we have lose-lose and we have no space in between. That's a big deal to get that, right? And it's not that they weren't true before, it's that they were true at a certain level of power, they're not true anymore. And so we have to figure out the win-win games where anyone's incentive and advantage is tied to collective advantage, because if I go hurt somebody and I engender their enmity and they have existential tech, I fucked myself, right? If I go increase the speed at which I can extract resources from the environment in a competitive game with others who are doing that, but we're heading towards the tipping points of chemical irreversibility of those peak resources in the environment. We just fucked ourselves radically. So we have to get over those bad Nash equilibriums, those bad, win-lose games. And so that is full incentive alignment, and that requires, so we can say, come back, we were saying, we have to close the loops in infrastructure, right? So we can think about the materials economy being a totally closed loop materials economy. We have to close the loops in human incentive, which means that the incentive of all agents and well-being of other agents in the commons are perfectly aligned. We have to close loops at the level of worldview, which means our definition of self and our definition of everything else in the biosphere are not definable outside of relationship with each other, right? The idea that I can advantage myself at the expense of other things goes, because that idea is existentially unsafe. It's not true. It's existentially unsafe in the presence of the level of technology we have. So the win-lose games require a separate sense of self, right? As soon as we have the idea of self as an emergent property of everything, right, as a fundamentally interconnected, dynamic, emergent property of the biosphere, then I can't get ahead at the expense of that which my life is fundamentally interconnected to. So the world, that's a closed loop at the level of self and other, right? Worldview has to close loop. But we could just say, because economics sits right at the junction of worldview and, we could actually say, if you succeed at any of those, you succeeded. Because you can only succeed at any of those by all of them succeeding. But it's a fairly succinct one to say, if we align the incentive of every agent with the well-being of every other agent in the commons, and we succeed at that, thereby internalizing all externality, thereby incentivizing only omnipositive behavior. Well, you can't do that without the right infrastructure that can actually measure omnipositive behavior, right? You have to have the kinds of sensor systems that can actually measure a balance sheet of the commons and make sure that the action is net enriching the balance sheet of the commons. You have to have the data processing that can take all that sensing and make sense of it. So that capacity requires tooling shifts and worldview shifts, but that is essentially what our task is. One way of framing what our task is.
Great. And that's good. So, yep, we're going to do this iteratively.
Okay.
So